Morning, students. Today we are in the continuity of the second unit, precision and gyroscopic couples, turning moment diagram. In the previous class, we have discussed about the effect of gyroscopic couple and what is the precision and the difference between precision and the gyroscopic couples and the effect of gyroscopic couple on naval ship and effect of gyroscopic couple on aeroplane and effect of gyroscopic couple on motorcycle and effect of gyroscopic couple on motor car. These are the mainly four elements while taking a turning of a vehicle towards the left side and right side. What are the gyroscopic couples or couples acting on the vehicle without slipping of a vehicle while turning either left or right side. Now the topic is turning moment diagram. What is the turning moment diagram? It's nothing but the turning of or otherwise the motion of a crank. So the turning moment diagram is also known as the crank effort diagram. Means while rotating of a crank, how much of energy is developed by the engine and how much of energy is useful to the machine. This is the main criteria, and that means how much of energy is developed and how much of energy is utilized. So that is the thing we need to find out. For that, we are drawing a graph regarding with the crank movement. Here, the crank movement will be representing in the angular motion, that is the angle of radians, that is pi, 2 pi, 3 pi, 4 pi, like that. That is 360 degrees. We are converting it to uh, radians. So here we are taking the effort or otherwise crank angle on the x-axis and y-axis we are taking the this moment or torque. So the turning moment diagram is a graphical representation of the turning moment of or crank effort for various positions of the crank. It is to be plotted on a Cartesian coordinates in which the turning moment is taken as an ordinate and crank angle is taken as a abscissa. Okay, this is the main thing we need to remember. Then coming to the crank effort diagram uses. So the uses of crank effort diagram or turning moment diagram both are same. So that is a area we are calculating which will gives the work done per cycle. So the TMD will gives turning moment diagram will gives the work done per cycle by the crank. Then work done per cycle will be divided by the crank angle per cycle that will give the mean torque. This is a major uh, torque which is to be remembered to finding the excess energy which was developed by the engine and what is the useful energy by the engine. Okay, this is a mean torque means that is a minimum baseline that is required. So more than that, that is an excess. Below the this mean torque line, it is to be excess requirement of the machine. So uh, we need to calculate the T mean. So after T mean is multiplicable by angular velocity, the crank gives the power consumed by the machine or developed by the engine. So these mean torque multiplied with angular velocity. And the area of the TMD above the mean torque. Just now we thought that the mean T mean, whatever the thing we need to represent in a line that will beyond the line. That means above the T mean, we call it as an excess energy that will be stored in a flywheel. So what is the flywheel? What are the purpose of flywheel? Okay, these topics will be discussed in the continuity. So the flywheel, which helps the design to, with that we are developing a design on the dimensions of the flywheel and the mass of the flywheel. So how much of excess energy we are getting from the engine that is to be stored in a flywheel. Okay, according to that, we have to design the flywheel and we have to create the model or shapes of a flywheel and mass of the flywheel. What is a flywheel? The flywheel is a device which is used to store the energy whenever the available is excess. So we are just now we have focused on the TME. More than the TME, that is called a excess energy developed by the engine. These excess energy will be stored in a some place that is called the flywheel. And at the same time, what the energy we have stored in the flywheel, it is to be it is to be utilized whenever there is a shortage of energy during the process of continuity of this smoother running of an engine. So these flywheel are used in IC engines and pumps and compressors and many multi-purpose engine to performing the intermittent operations such as punching and shearing and routing also. And this flywheel may be of a disc type and a ring type. Most of the cases we can see the flywheels in a ring type. Okay, these flywheels will helps in smoothing out the fluctuation of torque on the crankshaft and maintain the speed in a smoother manner within the prescribed limits. So, for any operation, we have to maintain a smoother function of an engine. So, this smoother function of an engine is to be maintained throughout the process. Otherwise, there is a fluctuation of energy or fluctuation of speed. Speed will be coming to the picture. Then, disk type. This is a disk type of flywheel, which is of only the diameter, the entire size of a diameter. Next, this is a ring type flywheel. So here the ring type means what is the ribs we are having at the center. So you can see the ribs. That means the entire wheel consists of a small rods with respect to concentrated on the center. That is more than six. 1, 2, 3, 4, 5, 6, 7. Okay, the sectional things we need to hear the main uh, implementation of energy storing is to be diverse towards these ribs. So this is a ring type flywheel. And this is the comparison between disk type and ring type flywheel. So for what purpose we are going for disk type and for what purpose we are going to ring type flywheel means the flywheels possesses inertia due to its heavy mass. So actually we are having a ring type of flywheel which are of not a solidical entire structure. It is a disk type. It is a fully of solid material. There is no uh, the weight of loss of energy. This flywheel we are calculating the comparison means. Okay, here M is the mass moment of inertia of the flywheel is given by I is equals to m omega square m k square, where m is equals to mass of the flywheel, k is equals to radius of gyration of the flywheel. For rim type, this k will be d by 2, where d is the mean dia of the flywheel. And at the same time, for disk type, k is equals to d by 2 root to 2. Okay, these are the values we need to remember while solving the problem. So it may be the problem how much of the weight, how much of mass moment of inertia, or how much of weight of a flywheel. Okay, if you ask means we need to know the k value. We need to substitute the k value based on the mean diameter of the flywheel. This disk type, and hence therefore uh, outer where the d is outer mean diameter of the flywheel. So why we are in the disk type only we are giving the entire diameter, the outer, that is outer diameter. But what is the in rim type we are calculating the mean diameter of the flywheel, since in the diameter of uh, this is called the, that means in rim type diameter, in rim type diameter disk flywheel, sorry, in rim type flywheel we are having the ribs with the outer diameter and the internal diameter. So we are calculating with it a mean diameter of the flywheel. According to that, we are calculating Ki as T by 2, and disk type we are calculating as outer diameter only. So hence I is equals to m k square. K square for that is ring. A ring means we have to calculate it as T by 2 whole square. So d square by 2 square means that is a 4. And I is equal to m k square for disk. D is the where k is equal to d by 2 root of. So k by 2 root of means d square by 2 square is the 4 into root 2 whole square is equal to simply 2. So 4 into 2, that is 8. Hence, for a given diameter of the uh, inertia and the mass of the tie wheel can be calculated for the disk type and rim type. And that is maximum fluctuation of speed. This is a majorly in every question we have to solve maximum fluctuation of energy, maximum fluctuation of speed. These are the two terms we need to find out for any problem. So while calculating the maximum fluctuation of speed, that means what is the fluctuation of speed is nothing but the differences of the differences between the maximum and the minimum speeds in a cycle. So speeds is nothing but the n1 minus n2 or n2 minus n1, whichever is the maximum. So there is no negative fluctuation of speed. So already it is a fluctuation itself. It is a negative. So try to make it as a positive in the left side, and that means a positive means it is a in the left side minus smaller y. And next, coefficient of fluctuation of speed. That is simply we call it as a C or K value. It is the ratio of maximum fluctuation of speed to the mean speed. So, maximum fluctuation of speed, that is, we have calculated as n1 minus n2, okay, by mean speed. We will call it as a mean speed as n. So, or otherwise, for nominal speeds, that means normal speeds, we are calculating n1 minus n2. For angular speed, omega 1 minus omega 2 by mean speed is mean angular speed, that is omega. And where omega, we know that 2 pi n by 60. This is a major important definition. And next is the coefficient of fluctuation of energy. So the notation is same, almostly C or K, but for energy we are representing it as E, and for fluctuation of speed we are representing with C suffix S. Speed, for speed it is F, for energy it is E. They are also the same. It is the ratio of maximum fluctuation of energy to the mean kinetic energy, or otherwise C suffix